right, so our first real lesson of this unit is going to be focused on one of the particular forms of a quadratic equation or quadratic function. So quadratic function can come in vertex form, intercept form, or standard form, and we'll kind of cover each one of those as we go along. But today we're going to focus on vertex form. Okay? And again, highlighters are going to be useful for you, kind of highlighting some vocabulary and then kind of where we see it on the graph and kind of putting it all together. So for vertex form, you'll notice up top, it says the vertex of the graph is always the point hk. So h is what is being subtracted from k, or from x, and the k is what's being added on outside of those, of that exponent, outside of that squared term. What additional piece is being added on? So we're going to find that vertex, that highest or lowest point, that point where the parabola turns, and then our axis of symmetry is always going to be what h is equal to. It's that vertical line through that x value. In this case, it's going to be our h in that equation. Okay? So when we're graphing functions, or when we're graphing quadratics, remember our parent function is always y equals x squared. So where there's nothing extra being added, multiplied, subtracted, is just x squared. And it's going to look something like this. Remember that the h and the k, so what's being subtracted from the x and what's being added on the end, that forms our vertex. So we don't even need to see the graph to be able to figure out where that vertex is going to be. We just have to identify it. The one thing to pay attention to is you'll notice that it's always minus h. So we're always going to take the opposite of what we see in there. So if we see minus 3, we know ours is going to be a positive 3. If we see a plus 3 in there, we know our vertex was, or our h value was negative 3. So just be careful of that subtracting in there. All right, so we're going to focus on some vocabulary. So first we're going to start with the a. So remember we had y equals a times x minus h squared plus k. So we're focused on the a, the part that's out in front that's being multiplied times the x value. If that a is positive, the parabola is going to open upward. Okay? So it might look something like this. It's going to go upward from that point. So the curve reaches a minimum. And in this case, our a value would be like our 1 that was being multiplied on there. You'll notice that depending on the equation, there might not always be an h, or there might not always be a k value. Those might be zeros, which is why you might not see them in there. So this up here is kind of the full version of it, but you might have some other version of it depending on what numbers are in the problem. So next one, when your a value is negative, so like my negative 1, this is going to open downward. Okay? So it might look just like the one up top, but headed in the opposite direction. Here, the curve reaches a maximum, kind of a highest point before it turns back around. Okay? Now, if our a value is greater than 1, so it's absolute value. So think of 1, 2, 3, 4, 5, or negative 1, negative 2, any of those numbers that are greater than 1, the graph is narrower, so it's skinnier. So it might look something like this instead of the wide one that we saw on the first one. Okay? And we'll explore more why that happens. But here we had a y value of 2, so it made it kind of half as big as it was before. It kind of shrunk everything a little bit. Okay? If a is less than 1, so think a tiny decimal or a tiny fraction, something less than 1 or less than negative 1 when we're dealing with its absolute value. So think like 1/2. It's going to be the opposite is going to be wider than the original function was. So we might have something that looks like this instead of our original. So looking at that a value can tell us whether it's going to get wider or skinnier. It's also going to tell me whether it's going up or whether it's opening down. Now we're going to focus on the h value. So that's this number in here. It's what's being subtracted from the x. So the h is the x coordinate of the vertex. Okay? That means it's also going to be our axis of symmetry. X is equal to h. So whatever that h value is, that's where my vertex is going to fall. That's the x value for it. And it's also where that axis of symmetry, that vertical line, is going to pass through. Okay? So the axis of symmetry is always x is equal to h. Okay? So notice that there's a negative in the model, so h is always going to be the opposite of what we see in the equation. So like for instance, I see a -2, so my axis of symmetry is going to be x is equal to +2, because they are subtracting away my h value, which was a 2. So that number being added or subtracted from x, that's our x value of our vertex, that highest point or lowest point. Now we're going to go with the k value. So in our equation here, k is what's being added on to the rest of the equation. It's that extra piece being added on at the end. The k is going to be the y coordinate of our vertex. So in this case, our y coordinate would be 2, or k is equal to 2. So the h is the one in with the x, the k is the one being added on at the end, and then our vertex is always the point h comma k. So we're just identifying those two pieces of information from within the problem. So for this one, my h is 3 and my k is 9, so it has a vertex of 3 comma 9. Here it says write the vertex form of the quadratic. So here's my h, here's my k. So I know I'm going to have y is equal to x minus -3, so that's plus 3 squared, minus, or plus the k of -7. So x plus 3 squared minus 7. All right, last little bit. So in our equations, we're going to focus on our domain and our range. So think of our graphs, those kind of parabolas going in each direction. If those arms were to continue on and on, we would find that the domain is always going to be all real numbers, right? Because the domain is our x values. So think about it, as that parabola keeps getting wider and wider, those x's keep going on and on and on. It's never going to end. The range, however, is not going to be the case. The range is our y values. So the range is going to depend on the vertex. Remember, going vertically is going to keep going in either the vertical or in the upward or downward direction, but it is going to get capped off at that vertex point. If A is positive, the graph opens upward, and the range is going to be y such that y is greater than or equal to that k value, kind of that lowest point. Okay? If A is negative, the graph opens down, and the range is going to be the opposite, y such that y is less than or equal to k. K is that highest point, so it's going to be everything below that point since it's headed downwards. And then our last piece, state the domain and range of our function. Okay? So my domain, we said is going to be x such that x is all real numbers. Okay? That's always going to be the case. But for the range, we have to look at our a value. So what's being multiplied out front. Well, in this case, since they didn't write it in, we know it's a 1, which is a positive. So that means my range is going to be y such that y is greater than or equal to, and then we look at our k value of 2. So it's going to be greater than or equal to 2. All right, so lots of vocabulary, lots of little details, but it's something that we're going to practice here coming up. But this is the end for today.